So I think it's now running. So once again, welcome to this KKMO training webinar. So today we shall be solving some problems, Math Olympiad problems. And as usual, if you wish to interrupt midway as we are going through the problems, please do so. Also, if you have any ideas that you think we can use, please feel free to share. So you don't need to wait to be asked. Simply put on your mic and speak when if you have something to say. So I also uploaded a bunch of videos from the previous sessions on YouTube. I think I will share the link towards the end so that if you wish to watch the ones that you missed previously, you'll be able to watch them on YouTube. So here's the first question. We'll just start the first question so that we can finish quickly and everyone can go back to their evening schedule. So the first question says the area and volume of a sphere are given by A pi and V pi respectively, where if A and V are both 3-digit integers, what is the smallest possible radius of the sphere? So we can, I don't know if I should give the audience a minute or two to try and work it out, or we just go to the solution. Okay, so I think we can just go to the solution. So we remember the statement of the question. It says we have the volume and the area, surface area, and the volume of a sphere as A pi and V pi respectively. So we are given that A and V are both 3-digit numbers. And the question is, with that information, what is the smallest possible radius of the sphere? So let's see how we went about it. So we know the formula for the area, surface area of the sphere and the volume of the sphere as 4 pi r squared for the surface area, and the volume is 4/3 pi r cubed. Now, if we take the radius to be capital R, then it means A will be the same as 4r squared, because remember we've said that the area is equal to A pi. So that means A must be equal to 4 times the radius squared. And using the same argument, we can say that the value of V here will be equal to 4/3 multiplied by the radius cubed. So that is, we fix the radius to be R. So we also told that A and V are both 3-digit numbers. So they lie between 100 and 1,000. So A itself, which is 4 squared, lies between 100 and 1,000. You get square roots, rather before you get the square root, divide throughout by 4 to get 25 is less than or equal to r squared and is less than 250. And then if you work with square roots approximately, you'll have 5 on one end and 16 on the other end, with a strictly less than or equal to sign, sorry, strictly less than side on the right hand side here. So this tells us that 5 lies between, R lies between 5 and 16. The same ideas can be used to find another set of values for R using the value of V and the fact that V is also a 3-digit number. We can set up this inequality so that 100 is less than or equal to 4 over 3 r cubed and strictly less than 1000. Something is not right. Okay. If you multiply throughout by 4 over 3, then I think you will have 75 on this side. And sorry, multiply throughout by 3 over 4, not 4 over 3. You will have 75 on this side and 750 on the other end. And then if you work with the cube roots, approximately you will have 5 on the left-hand side and 10 on the right-hand side. Okay. So with this intervals for R, we can try to estimate the value of R. So we want V to be an integer. So if V is an integer, R must be a multiple of 3 based on this formula. We want this to be an integer. The only way that can happen is if this quantity here is a multiple of 3. And that means R itself must also be a multiple of 3. Now, in this interval, the only multiples of 3, because we can't go beyond 10, this took us up to 16, but because of this second inequality, we cannot go beyond 10. The only multiples of 3 will be 6 and 9 in that interval. And you can check that the smallest possible radius is therefore 6. I hope this makes sense. So you basically reduced the possibilities to these two, and then the smallest is 6. 6 and 9 are the only possibilities because R must be a multiple of 3. And between 5 and 10, we have only those two, 6 and 9, as the multiples of 3. So that solves the first problem. Any questions on this? Hakuna maswali? Okay. So we can move on to the next question. So this one says that some unit cubes are assembled to form a larger cube, and then some of the faces of the larger cube are painted. So we don't know how many of the faces are painted, but some of them are painted. So after the paint dries, the larger cube is dismantled again into the unit cubes, and it is found that 96 of these have not been painted at all. So the question is, how many faces of the larger cube were painted? Okay. Let's see how we can solve this. So let's assume n is the length of one side of the larger cube. Is there a comment or something? There was I may not be able to check the chart, but if you have, it might be better if you excuse me, if you open the, put on your mic and speak if you have a question. So anyway, let's go back to the solution. If suppose we state that n is the length of one side of the larger cube, that means in total it will have n cubed unit cubes. So a unit cube is just a small cube of unit length, of side unit length. Now, definitely, the number of unit cubes would be bigger than 96 because from the question, you can see that 96 will not be all of the cubes. They are just the ones that have not been painted. So that guarantees that n, the number of unit cubes must be more than 96. And this means that n must be greater than or equal to 5. Because if you take 4, it will be less than 96. We need to be more than 96. So 5 is the smallest value that n can take. Now we can consider the interior unit cubes. So all the interior unit cubes are not painted. So that means you remove all the layers, the top layers on all sides, so that you'll be left with n minus 2 cubed. And these will be less than or equal to 96. We know that because we are sure that these interior unit cubes are definitely not painted, so they cannot be more than 96. So again, after simplification, you can conclude that n must be less than or equal to 6. So it means n is either 5 or 6. Those are the only two possibilities. So we need to check which of them will make sense. So if n is equal to 5, we can consider, we'll check manually. So if n is equal to 5, we can consider the following situations. We are aware that at least, as a minimum, one of the faces must be painted. So we start with one face. If one face is painted, then the number of unpainted pieces will be 125 minus 5. That gives us 100. So it can't be one face in this case, because we need the number of unpainted faces to be 96. So what about the next case? If two faces are painted, then we'll have 100 minus 25, and the smallest next number that you can deduct from this is 20. So that means you pick an adjacent side of the larger cube to take off 20. The reason you'll take off 20 is because 5 of them were already painted, because these two are adjacent. So the next smallest number you can remove is 20. So that gives you 80. So it means you cannot attain 96 if n is equal to 5, because initially, if you paint only one side, you can get 100 unpainted pieces. If you paint two sides, you can get 80 pieces. So the other way you could have done this is to paint a side which is not adjacent to this one, so that you have 25 minus 25 here, which again will be less than 96. So we can see this will not work, because if you paint any more faces, now the number of unpainted unit cubes will just go lower and lower. You'll never get 96. So 5 cannot work. What about if n is equal to 6? If n is equal to 6, you can again check this manually. It is possible to end up with 96 unpainted unit cubes. So you pick one side, paint, the next adjacent side gives you another 30, the next adjacent side gives you another 30. Then you can pick one side which will give you an extra 24. To get, and when you work this out, you should get 96. So for n is equal to 6, if you paint 4 faces in this manner, you will end up with 96 unpainted unit cubes. So that means our answer is 4 faces. 4 faces of a larger cube were painted. Exactly 4 faces. You can't get 96 in any other way. It's only by painting 4 faces. Maybe this would have been better with a diagram. I didn't prepare any diagrams for this one, but I hope it makes sense. You can hear me? So at this point, usually you would have had to do some trial and error. The reason I have this as a direct answer is because after some trial and error, you already have the final answer. But this may not be a direct computation. You may have to arrive at this by trying a couple of possibilities. So I hope that makes sense. So let's work on the next question. So this is question 3. Are there any questions on the previous one? I just moved forward without asking. Maybe someone has a comment, question, suggestion. Maybe the other way I can put it, is it making sense?
Naona iko sawa, tunaweza endelea tu.
Tuendelee mbele. Okay, that is good. So question 3. So this one says, if the solutions of the inequality x squared plus ax plus 6 is less than or equal to 0, satisfy this inequality. The solutions lie between c and 6 exclusive. So the question is, can you find the value of a plus c? So this is a quadratic equation, and since the coefficient of the highest power is positive, it means it's a quadratic equation that's facing up. So that's one thing we can note about this. Now, if the solutions lie between c, if the graph is less than or equal to 0, it means it's below the x-axis between c and 6. It means the roots must be c and 6, because at the point where it cuts the x-axis is where you find the roots. So after that is when it will go below the x-axis. So it means c and 6 must be the roots of this quadratic equation. Let's see if I can. I think there's a way to draw, but it won't be very nice. So it will be something like this. So now you can see if the roots are between c and 6, it means one of the roots is c, the other one is 6. And after this, you can see the graph is now below the graph. After this point, the graph is now below the x-axis within that interval. This drawing is not so good. Let's clear this drawing. So I'll just redraw it again. So it's usually it should spread out going that way. The way I've drawn it, it looks like it's curving backwards. So that will be your C, and this will be 6. So between there, C and 6, it's below. So we can use this information to find the solution to this problem. So as I've illustrated, from the information, we can conclude that the roots are C and 6. So if the roots are C and 6, it means we can write, we can factorize this quadratic equation in this manner. These are the two factors, x minus c and x minus 6. When you expand that, you get x squared minus c plus 6, x plus 6c. So we can compare both sides to find the value of c. Obviously, if you compare the constant term, here it is 6, here it is 6c, that means c must be equal to 1. And then a should be equal to c plus 6. We know c is 1, so a will be 7. So we've found a and c, and therefore we can add them to get a plus c is equal to 8. So for some reason I did not complete this. The answer would be 1 plus 7, which is equal to 8. I believe this is Making sense?
Sure, it's okay.
Okay. So now we usually do only 4 questions. So I'll go to the last problem of the day. So the last problem of the day says a 4-digit number consists of 2 distinct pairs of repeated digits. So as an example, we can see this 2211, 2626, 7007. So this kind of situation. So the question is this: find a total number of such integers that are divisible by 7 or 101, but not both of them. Okay, so that's the task. We need to find all such numbers which are divisible by 7 or 101, but not both of them at the same time. So let's see how we go about this. So there are 3 cases to consider. First of all, we make the following observation. We can pick that the first digit must lie between 1 and 9 inclusive. Then the other digits, the second digit rather, if it's not the first digit, can be any number from 0 to 9. So there are 10 options for the second digit. And we have 9 options for the first digit, as we at the beginning. So one way you can do this is to have, remember also that if you check the question says they are distinct. So A will not be equal to B. So A is not allowed to be equal to B. So one possibility is where you have AB as your 4-digit number. Now you can write this out as 100 multiplied by the 2-digit number AB. Then you add the 2-digit number AB. So this is the same as 101 multiplied by AB. So we need to find numbers which are divisible by either 101 or 7, but not both. So this is automatically divisible by 101 because 101 is one of the factors. So we need to knock out all the numbers which are divisible by 7. So if you want to knock out the numbers divisible by 7, you need to find all the 2-digit numbers divisible by 7. And there are 81 possibilities in total for this AB. Now, those that are divisible by 7 are 12 in total. You can actually list them. You can list them from, the only one you will not list is 77 because you don't want the 2 digits to be the same. But all the others, I think, will be fine. Is there any other one that you can start with what, 14 and keep going in steps of 7, 21, 28, 35, 42, 49, 56, 63, 70. So 77 will not work because you don't want A and B to be equal. But you could count them, there'll be 12 in total, but we don't want them in there. So we subtract them from the 81 to get 69 possible cases of such numbers which are divisible only by 101 and not by 7. So that's one case. So the second case, you use similar ideas. You can write this 4-digit number as 11 multiplied by 100 times A plus B. I hope this is clear. So clearly this number is not divisible by 101. It can't be divisible by 101 because 100 multiplied by A will not be divisible by 101. And also the second, this B will not be divisible by 101. So we just need to look for values of A and B, which will make this number divisible by 7. So if you do this by inspection, you'll find that 11 pairs, these 11 pairs, when A is 1, B is 5, that will be divisible by 7. When A is 2, B is 3, that will be divisible by 7, and keep checking until you exhaust all the pairs. So we have 11 possible numbers of this form that are divisible by 7. And clearly from the factorization here, this number is not divisible by 101. 101 is not one of the factors. I hope making sense so far. So then there's one last case to consider where the two B's are in the middle and the A's are at the ends. So you can rewrite this as 11 multiplied by 91A plus 10B. There's some work involved there for you to get it. How you do this would be what? Let me see. Let me try to. Oh, what have I done? I need to take it back to. Okay. So you can write this as say what, 1,000 multiplied by A, right? Then you'll have 100 multiplied by B. When you put it this way, you will see how the factorization came about, and then plus you have 10B. And then the next one would be what? The ones digit will just be A. So you can split this number like this. Now, so if you add this 1,000A and that single A, you end up with 1,001A, right? And then on this other end, you have 110B. Now they have 11 as a common factor. So you have 11 out here. And then inside here, you'll have 91A plus 10B. That's how we obtain. So that's how we obtain this thing here. I think that should be clear. So again, clearly from the factorization we have, 101 is not a factor. So we don't need to worry about 101. We just need to find numbers of this form that are divisible by. Numbers of this form that are divisible by 7. So we already know that 91 is divisible by 7. So for this number to be divisible by 7, this second number here must either be 0. If it is 0, then we are done. Or it must be it must be a multiple of 7, right? So if B is 0, then we have how many? 9 values. All the other 9 values of A will be possible because we don't want A to be equal to B, right? If B is equal to 0, then we have 9 values. Now, if B is equal to 7, because we want this to be a multiple of 7, any of the other numbers will not give us a multiple of 7 here. So if B is equal to 7, we have 8 possibilities for A. The reason we have 8 possibilities is out of these 9, A cannot be 7. So you're left with only 8 possibilities. The reason for that is that A cannot be equal to B. So if you pick B equal to 7, you knock out 7 as a possibility for A, and you're left with only 8 options on this side. So those two cases are mutually exclusive, and therefore you can add them. 9 plus 8 will give you 17 possible numbers that are divisible by 7. Again, we saw this is not divisible by 101, so 17 is what we need. The number is divisible by 7, but not divisible by 101. So if you add up the total, we should have 69 plus 11 plus 17, which is equal to 97 numbers, which are divisible only by 7 or 101, but not both. So in fact, the only ones that are divisible by 101 are these 69. The remaining 28 are divisible by only 7. I hope this makes sense. There's a bit of counting principles involved here at the beginning. For instance, here it says if you have, so the counting principle says the following. Let me see if I can. Suppose you have 2 boxes to fill, and you have, say, A ways of filling the first one, and after filling the first one, you have B different ways of filling the second one. So the total number of ways of filling the 2 boxes will be A multiplied by B. This is called the product rule for counting. So here the reason we counted 81 is because we need to fill up these 2 boxes, one with A and the other one with B. So for the box A, we have 9 possibilities to fill in. So box A will have 9 possibilities. And that is 9. Now the second box B that we need to fill after we filled box A will also have 9. It would have had 10, but we can't have 10 because we cannot repeat the number that we've picked on this side. Once we pick a number here, we cannot repeat it on this side. So we are left with 9 possibilities instead of 10 again, because from 0 to 9, there are 10 numbers. But since we can't repeat the number that we've already picked here, we're only left with 9 possibilities for the second box. So if you have 9 times 9, you get a total of 81. But again, we don't want all the 81. We want to remove those that are divisible by 7. We have to remove them so that we are left with only those that are divisible by 101. So that's why we remove the 12 to have 69. I think other than that, I think the others do not involve any strange concept. Rather. I don't know if I'm making sense. Can anyone hear me? Maybe.
Yes, you're making sense, Dr. Ari.
Okay. So that brings us to the end of today's class. I would welcome any questions. If you have any questions, please share them now. Someone earlier asked about round 2. We are finalizing on the second round results, so hopefully they'll be out by tomorrow. They should be available on the website. We'll post them in the group as well. Let me share the link as you think of any questions that you may have. For now, I can share the link to the YouTube videos for the previous. I uploaded some new ones today. Let me see if I can find it. Where is it? I think I should be Let me switch my account to here. Connection is a bit slow, but it should be ready in a minute. Need a playlist. So I'm going to put the link to the playlist, which has all the previous videos from the first one up to the one for 2 weeks ago. You should be able to watch them in the on YouTube. Okay. There you go. Chat. So I have put the link in the chat. I hope everyone. I've sent to only one person. No, I need to send to everyone. There, I've sent to everyone in the chat. So if you have any questions, you can ask. If you have any comments, please feel free to share. If you have any ideas are welcome. If there's something we can do to improve the sessions, you can also share. If you also enjoyed the session, you can also say so. If you found something useful, if you learned something new.
Good evening, Daktari.
Good evening.
Yes, I enjoyed the session. I came late though.
Okay. I would make the recording available. Hopefully, I'll get the guys at IT to send me the recording tomorrow, then I can upload it.
Okay.
And thank you for your comment.